All right. So now we're doing freeCodeCamp, JavaScript algorithms and data structures, intermediate algorithm scripting, sumPrimes. All right. So a prime number is a whole number greater than 1 with exactly 2 divisors, 1 and itself. For example, 2 is a prime number because it is only divisible by 1 and 2. In contrast, 4 is not prime since it's divisible by 1, 2, and 4. All right. We're going to rewrite sumPrimes so it returns the sum of all prime numbers that are less than or equal to num. All right. So we're going to have to sum something, right? But you know what? We're looking at this, and how do we even know if it's a prime? Wouldn't we have to do another function for that? The answer is yes, of course. So what we're going to do is we're going to be using a callback function inside of here, but we need to make the function to call back to. All right, hopefully that makes sense. So we're going to start off by creating a completely different function that's going to be supporting this function, right? So we'll start by saying function isPrime, like this, and we're going to have the num as the thing here. Let's say number just so we don't get confused, right? We're going to have number as the argument or as the parameter, just like that. All right. So how do we know if a number is prime, right? So clearly, if it's less than 2, it's not going to be prime because 1's not prime, and also neither are negative numbers or 0. All right. So what we're going to do, we're going to start off by saying if number is less than 2, what we're going to do is say return false. All right. And we're just saying isPrime, so it's going to be returning a Boolean, right? So now we're going to do a for loop, and we're going to go through all the numbers up to the number to see if those numbers are, if that number is divisible by the I. All right. And I'll show you what I'm talking about. So we're going to say for let I equal, we don't need to do 1 because we already know it's going to be divisible by 1. If I equals, we're going to let I equal 2, and we're going to say, while I is less than or equal to the number. But the thing is, think about it like this. Think about the number 100, which is definitely going to give us false. If we do if we do 2 times 50, it's going to equal 100. If we do 4 times 25, it's going to equal 100. If we do 10 times 10, it's going to equal 100. So why do we need to check if 25 times 4 is going to give us 100 when we already know that 4 times 25 is going to give us 100? We don't. That's the thing. So instead of that, we're going to wrap this thing up. We're going to wrap this number up in parentheses, and in front of it, we're going to do math.square root. All right. So if you've never seen this before, I don't know if we've done it yet. Basically, it's just the static method that returns the square root of a number. Just that easy. All right. So now we're going to go up to that, so we don't have to check half the numbers. All right. So we don't have to check twice the numbers. So what we're going to do here is we're going to have the semicolon. We're going to do I++. All right. So this way we can save some time while doing this thing, just in case the number is like 70 bajillion, you know? All right. So now we're going to do another if statement in here, and we're going to check to see if the number is divisible by I or not. So we're going to say if number remainder operator I equals 0. All right. So if there is no remainder and it is actually a divisor, we're going to return false. All right. So we've got that, and that's taking care of the for loop. And so if it goes through this and returns and it doesn't return false, and this one too, what we're going to do is return true. All right. So let's come down here, and we're going to say console.log isPrime 100 false. All right. isPrime 7 true. It is prime. So it does work. We know that this thing works. So now that we got this thing taken care of, we can use this just like if we would use the map or anything else. we can use this inside of here, right? So what we're going to do with this is we're going to say, what we're going to say here is first, let sum equals 0, all right? Naturally, with any sum, we're going to do that first. So now we're going to do the for to see if the number leading up to this number is prime. So we're going to do a for loop, seeing if the numbers leading up to this number are prime. And if they are, we're going to sum this to the sum. We're going to add them to the sum, I should say. So we're going to do for let I equal 2 again, right? Because we're not going to be summing 1 in there. And then we're going to say, well, I is less than or equal to num, because num is going to be included. We're going to say I plus plus, all right? And then let's have the curly braces, and we're going to do if, right here, we're going to do if is prime num, pardon me, I, all right? So we're calling this function inside of here, just like if we were to do a map function, pardon me, the map method, or anything else kind of like that. We're just calling this thing inside of here. So if is prime is prime I is true, what we're going to do is we're going to say sum plus equals I, all right? And then after that, we'll just do a console.log sum, all right? And you see we've got 17, all right? So let's just go through the primes up to 10 just so we can check. So the primes up to 10 are 2, 3, 5, 7, not 8, not 9. All right. So 2 plus 3 is 5. 5 plus 5 is 10. 7 plus 10 is 17. Looks good. So let's come over here. We'll say return sum. And then right down here, we'll come inside of this. We'll wrap this thing up with parentheses, and we'll say console.log. All right. And if we got 17, looks good. Run the test. Looks good. And submit it. All right. So now we're on to smallest common multiple. And we'll see you next time.